Alrighty guys, what is up? Daddy here today, and this is a video that I've been wanting to make for a while. It's something that I work on, pretty closely to one of my research projects, and in the last couple of days, Bitcoin has made 52-week highs as far as price goes. So that it was appropriate to go ahead and make this video for several reasons. But basically, what we're going to be looking at today is how to set up a full Bitcoin node. And what that is a node, or essentially an extension of the Bitcoin network, that validates and keeps transactions, or basically keeps a copy of the ledger like on that local device, or on that node, shall we say. So this is different than mining. You're not actually using compute to go through and actually put transactions onto the network, or mine, or put, I guess the best way I could say it is put blocks onto the network. Trying not to get in a rabbit hole with all of that, but it's different in the sense that you're basically just keeping a copy of the network, and you're allowing other people to, in a distributed way, get a copy of that from you, so that everybody has a copy of the agreed upon Bitcoin blockchain. So that's basically what it is. And the next question is, why would you want to do this? And one reason might be that you just are an altruistic person. You want to contribute to the health of the network, because unless people do this, the network basically falls apart. Another reason is, you like enhanced privacy. So for example, if you have your own node, you have a full copy of all the transactions. Basically, you don't need to go to any other third-party server to validate transactions. You have your own full copy, so there is no reason to go to any other server than your own. So, for example, you wouldn't have any logged requests to any other servers. Nobody would know what you're doing. So that's one reason people choose to do it. It's more reliable because, like I said, you always have a copy on hand. You don't have to depend on other nodes being up and running. Like I said, supporting the ecosystem, for learning, education, or research purposes, which is kind of what we'll be doing it for today. And then basically, some people just like having control over their own node. And kind of with that, you can have your own wallet, and you can manage all of your own personal transactions through the wallet that's attached to the Bitcoin core. So there are some other really interesting things that can be done with your own node. But for us today, what we're going to be looking at is setting ours up for basically research purposes. And for my own purpose, I would like to have a full copy, up-to-date copy of the entire Bitcoin ledger locally available at all times. So that's my main objective, and I'll explain that why I want that a little bit later. But for now, let's look at the requirements. So you need any OS is fine, pretty much. There's a lot of different options: Windows, Mac, Linux. You could run it on run it with ARM. So run it on a Raspberry Pi if you could make that work. Seems a little bit resource light to me, but that's beside the point. You need 7 gigabytes of free disk space, which this also seems low. I think this is if you're running a pruned copy, which means you only have like some of the more recent blocks available. You don't have a full copy of the ledger. You also need a read-write speed of 100 megabytes, which most people would have these days. You need 2 gigabytes of memory, which again, most computers are probably going to have these days. You do need a reliable internet connection. And at least here in the United States, this should be definitely something most people have. However, this does use a lot of data, and you probably are going to need some kind of unlimited plan. Otherwise, you're going to, especially at least in the first IBD, or the first part, which is the initial block download, it's going to be pretty data heavy, and you're going to end up going over for maybe a month, or the first month, while you're getting most of the blockchain downloaded. And then also one thing that's nice is if you could keep it on 6 hours a day, that helps contribute. That's kind of the altruism thing where, you're not only helping yourself, but you're helping others because they can access your node to, get a copy more or less. All right. So that's the main things here before we really jump in. So what we're going to do here is we're going to start. I'm just going to show you the node that I have up and running. So to give you some context, this is one of the main server I have downstairs. And we are running a container on it. It's been up for about 3 hours. And let me just get rid of, let's clear this out. And inside, so if we go look at the other, we're actually now inside of the container. So this is what everything looks like inside. And if we look at the blocks, we can see that it is just in a distributed way downloading all of the blocks from all the peers, shoving them in DAT files, and then they're all accumulating in this directory. So the way that this works basically is other peers on the network will have a copy of the ledger, and you are basically accessing as many peers as possible, and you're saying, hey, I need blocks, and they're just packing you up and sending you the blocks you don't have, and then you're storing them in these basically storage files called DAT files. So every time that you fill one up, 128 megabytes, you'll move on to the next DAT file, and so on and so on and so on. And these are basically just great big old binary storage devices. So that's how this kind of works. It's almost like a BitTorrent where you're just downloading kind of in a distributed fashion from peers on the network. It works a little similar in that regard. But anyway, so this is how it works. And if I keep refreshing the page here, you're going to see that this number keeps growing and growing and growing. But these block.dat files, blk. Some 5-digit number .dat, this is what actually houses the block header and then all the transactional data. It is in binary, so for me, I have written a parser that actually goes through and parses out all of the binary data into a JSON format, but you could use any format that you want, XML, whatever. And this way it's readable, and you can actually go in and you can start doing some analysis of the underlying transactions on the network. So just a validation of why this is important, or why you might want access to this information. And that's why I do it, why I'm setting it up. So let's get into it as far as what you need to do the same. So I've typed out all of the commands. What you need to do first is, and we'll swap back over to the larger container, because we actually, ideally we need to start up another container. I've already got this one running, and it's downloaded quite a bit of data, so I don't want to reset it. And because of networking, I don't want to have to reset up a whole other container, because it would be a pain. So I'll just explain all of this, and in the end, I'll show you how to start and stop and get everything going. And then I'll also put this in the description, so this should give you pretty much step-by-step instructions of how to set everything up. But what we're going to do first is we need to create a Docker container. So the first thing we need to do is we need to make sure that our container is set up correctly. So the command here is we're just going to run a Docker container. We want to run it detached. We want to run with interactive shell. We want to also map a volume. So for example, this is kind of where it comes into play. Especially if you are not using a pruned version, you're using the full version of the ledger, you really need to think about where you're going to store this. Because for me, the reason I have everything here in this LTS, this is long-term storage, I have about 35 terabytes worth of storage here. So more than enough to handle, the probably 600 gigabytes right now that the blockchain is. So anyway, you need to plan a little bit in as far as where you're going to be storing this, because it's important. If you don't, you might run into a case where you're not even able to download the entire chain, or in a year it might be something where you have to figure out how to increase your storage. So anyway, just keep that in mind, and this is the reason why I've set mine up this way. And then it's never a good idea to keep your information in a Docker container. I always like to have information in an underlying volume on my server, so that way in case something happens to the container, nothing happens to this data, and I don't have to re-download all of it. So anyway, this is just a volume this is the physical machine, and this is the container, and they both share this particular file. And then for me, I like to map some arbitrary port to port 22 so I can SSH into my container, personal preference there. And then I also, this is the mandatory mapping. So this is 8333, which is the port that Bitcoin nodes share data through. So this needs to be open and available. And since we're running it on a Docker container, we need to map it to some external port on our server. In this case, I chose 5833 because I don't like to really map, for a number of reasons. I don't like to map the port to its exact port number on my actual external server that this container is hosted on. In this case, it probably would be fine. I just like to use these ports I know that I'm never going to use for anything else. It gives me more flexibility, and sometimes you'll run into issues where you'll have two programs that have to use the same port, and one is really difficult to change, and I've had that happen before. So, in these situations, I always just like to map it to some arbitrary higher port that I know isn't really going to be used for a lot. And also for security, I can map this all the way through to the router, and I don't have to use the exact same port. It's a little bit less obvious for security reasons. So anyway, not really any real reason. It's much easier just to map it to the exact same port, and in fact, you can totally do that. You can just take the 5 away and map it to the same port, and I'll explain it a little bit better later with a diagram. But one of the main reasons I think it's good to use this in a container, not only for security, but also for resource management. You can set the number of CPUs and the memory that you're going to use with this container, which will, make sure that it is constraining itself to a certain amount of resources on your local machine. And depending on what the resources you have at your disposal, this is more or less important. And then here we're just setting some kind of name that makes sense so that we can remember. So I'll go ahead and leave that because I'm gonna have to change it to run it. And then we're just using the regular Ubuntu 22.04 image, which you can pull down from Docker. So you can literally write the command docker pull Ubuntu 22.04. And as long as you have Docker installed correctly, it will pull it. Well, and you spell Ubuntu correctly, it will pull down that command or pull down that image. And then bin bash just allows the container to stay alive, basically so that you can work on it. It just opens a shell in the container. All right. So the next thing that you would do is you're going to run sudo-apt update, sudo-apt upgrade, install sudo. You're going to install these, optional here. You're going to install these basic packages, and then you're going to create yourself a user. So for me, I created just user. Oh, sorry, so let's just say that you created the Docker container, and just for to show you that it works, we'll go ahead and we'll change these, and we will go ahead and run it. There we go. So as you can see, it's up and running now. It's basically a copy of this, just one port higher, and named a little bit differently. So I'm gonna go ahead and kill it because we don't need it. All right, so now let's hop back into the actual container. So this is the BTC core container we've got going. And so in this container, you would run these commands, and then you would create yourself a user. So as you can see here, we have user. The password I've set to this, set it however you want. Give it sudo permissions. Okay. And then I always install OpenSSH server. You feel free to do whatever you'd like. And this is just basically setting up, changing the default shell to bash, and then installing SSH keys so it's easier to access. But again, these are personal preference. You can also just go and attach a shell to Docker, and you can work through that. It really makes no difference. Okay, now that we're in the container here, what we need to do is we need to come down here. And again, depending on what you're doing, if you have it set up same as me, where you're just using some volume, this is the volume that I picked. So everything is going to need to be in this BTC core folder. So cd into BTC core, and then run wget. So this is going to pull down a zipped version or a tar file, a zip tar file of the Bitcoin Core 25. So then you can unzip that with the following command. And then inside of here, you can see the bin with all of the CLI, different utilities, all kinds of stuff. Example configuration file, a README, all that good stuff. And then what we're going to do is we're going to take basically this bin, so all these executables here, and we're going to do what's called install, which basically just means, hey, put this here and assign certain permissions so that that they can be run. So this is the new place where the copy is going to be, and your user by default has access to this bin. So you should be able to run basically any of these executables that are in the bin here as the user named user, and you should be able to run them. So that's the beauty of this install here. All right. Next thing we need to address here is we need to look at the firewalls, port forwarding, and we need to look at address reservation. So this is the networking here is really, I think, probably one of the most challenging part. So sorry, let me pull up my whiteboard where I have all this drawn out. And here we go. Just give me 1 second to load. All right. Now, one thing I did forget, unfortunately, and I'll just draw it in really quick, is there's wow, that was bad. There is a firewall that sits in between this port forward. So this is with UFW, uncomplicated firewall. So we'll address in just a minute how to set that correctly. And then the other thing we need to be aware of is we need, there we go, green, is we need to make sure that this internal IP address that we have for our server or whatever machine is hosting this container, we need to make sure that we set an address reservation. Otherwise, when we do go through all this trouble to set up the port forwarding, your DHCP server on the router may, if you turn this computer off or reset it or whatever, it may assign a new IP address, and then this port forwarding will no longer work. So let's go ahead and let's walk through this step by step. It's not really, it looks complicated, but it's really not. So you have the public internet, right? And you need to interact with the public internet to get information from the peers on the Bitcoin network about the state of the blockchain, about if there's any new blocks available, and you need to pull those into your own system so you can have a complete copy of the ledger. So what that's going to look like is you have a public IP address. So if you do something like type in whatismyip.com, then it will show you your public IP address, and then the other peers are going to basically find you and reach out or be able to communicate with you through port 8333, or they're going to look for that port to be open on your home router. And that's what you're going to send and receive traffic through. So the first step is going into your home router and then setting up a port forward to whatever internal system or whatever internal IP address is correspondent to the home server or home machine that you will be hosting this container on. So for example, in this case, this server, so this guy right here, this 46x1 server that I have here, is hosting this Ubuntu container. So in this port, or in this container, what we're going to do is we're going to tell the router, say, hey, whenever you receive traffic on port 8333, we want you to forward it to this internal IP address, and this is just a made up one, but 192.168.23.5 at this particular port, so 58333. So okay, so basically all traffic that comes in is going to be sent to think about it, the outside of your machine, so your external machine, which is the server itself, and the server is going to say, okay, well, we have an internal Docker container running, and whenever I get stuff on this port, we're going to send it in to 8333. And this is normally Docker uses an internal networking structure of like 172.23, like whatever. So just to kind of map out what it would actually look like. But what that's going to look like is your external server is going to receive it on this port, and then it's going to send it internally, because we set up our Docker container. We set up our Docker container with the following constraints. We said, hey, when the external port, so the external machine, receives stuff on 58333, send it to the internal container port of 8333. So that's what the server that's running on the container. So if we go back one more time to this, inside of this, there's going to be another little box, if you think about it, where there's going to be basically the Bitcoin server. So if you think about this, is going to be BTC that's running in here. It's going to be looking for data that's coming in on this port 833. So all of this convoluted stuff we just did is to get the data from this port on your home router all the way to this internal port on Docker container, so that the server, or the service, I should say, that's running inside of here that hosts Bitcoin Core can get the data from the external port of the Docker container port 8333. So I know a little bit complicated. And again, one thing you could do is just make everything port 8333. There wasn't really a reason for me to do this. I just sometimes like to make life more complicated, but for all intents and purposes, you could just make it port 8333, 8333 instead of 5833, and then just have everything forwarded all the way through, and it'll be the same thing. So, and the address reservation, so this is going to be at your router. Your router has, or most people's routers these days have their own DHCP server, and you need to go in and basically say, hey, do what's called setting an address reservation, and that will basically say every time that this machine, so that's just too complicated. Basically, this will be the IP address for this particular machine forever and always. So you're assigning IP address to a MAC address, and regardless of whether you reboot your machine or whatever happens, that IP address will always remain that machine's. So you'll never have to worry about it changing or being reassigned. So, and do that indefinitely, or do it for like whatever the longest lease period is, so you don't forget, and like a year's time it resets. But anyway, the last piece is we need to talk about this UFW, or uncomplicated firewall, which may or may not apply depending on whether you have a firewall set up. But for me, so back again to the server. So in the diagram, it'd be this blue guy, and there's a firewall that's around it. And what we need to do is we need to make sure that we allow. So let's look at sudo UFW status. So as you can see here, we have TCP, or sorry, I'm allowing in port 22. So this is basically SSH, so that I can SSH into the server. And then I've also allowed in port 58333, 58333, which corresponds to our picture here, 58333. Otherwise, if you don't open that up, this firewall is going to block any incoming traffic that goes to that port. So just be aware that your firewall, if something's not working, your firewall actually may be an issue, and you might need to make an exception in your particular firewall to make this work. So, all right, Cool. So that I think addresses the networking stuff. I know it looks complicated. It's really not that bad. And one thing I do want to mention here is I wish I could give you guys more detailed information about how to actually set up the port forwards and the address reservation and those kind of things. But this is really machine specific. So for example, my Deco X55 router has an app that I can go in and go into advanced settings, and I can, do address reservation and port forwarding all through the app pretty easily. But some have like basically a web hosted server inside of them, and you have to go interact with them through that. This really depends on your server. So my best advice here is just look at the manual for your particular device, and there should be either the instructions there or maybe a good YouTube video on how to do it. So give it your best shot, and if you need some help, just leave a comment and I will do my best to help you there. Okay, so next thing we need to do is we need to make a directory called .bitcoin. So by default, everything that the Bitcoin core does is through the whatever user that you're using. So I know it's kind of confusing. I named my user, but whatever this is, whatever you're signed in as, it's going to use that as the default location to look for this folder, and then the configuration file lives inside of it. So what that means is inside of this .bitcoin folder, there's a bitcoin.conf configuration file. So what we need to do is first we want to create this directory, and then we want to copy from this thing we downloaded and extracted. We want to copy the configuration. So we want to copy this from here into this directory, and then we also want to update one value. So we want to update the data directory, and this just specifies basically what folder all of the data is going to be stored in. So in our case, we want it stored on here in this mount BTC core, right? Because on the underlying server, this is in long-term storage where we have 36 terabytes of memory, 36 terabytes of storage. So in this case, I know it's going to be safe, and I know it's going to have enough room to house all of the data. So anyway, once you set that up, the rest is pretty easy. The next thing we're going to do is we're going to run Bitcoin D, and just to show you what that looks like, I'm going to go ahead and so I have it running in the background right now, so I'm going to go ahead and stop it. So the command is bitcoin CLI stop. So we'll go ahead and we'll stop this guy, and we'll just give that just a minute, and then what we'll do is we'll run it in the foreground. So we'll run it in the terminal, and it will get, it'll show what the spool up process is like. So you can kind of see how all that looks. So let's see if it's ready. So there we go. It's spooling up. It's running all of its checks, checking for a cookie file. There we go. All right. And then it's actually going to start connecting to the peers again, and it's going to start downloading and grabbing data. So the initial process is a little bit slower because it needs to validate basically every block, or it goes through like a validation process for every block before it actually starts ingesting them. So it could take a couple of minutes before it actually starts the first time, but once it does it, it's pretty quick. You can start it and stop it pretty easily. And then, so one thing we'll do here is while it's running, we'll go and do some other checks. So one thing you want to check once you have everything set up is run this command, and this is going to go out and connect to some of the peers, and it's going to grab some blockchain info. Ooh, excuse me. All right, so here we go. We can see that we're still in the initial block download. So there we go. So this is the current best block hash, the current difficulty, what chain we're looking at. So you can see a lot of different stuff, and it's grabbing this. It's grabbing this and presenting this to us. The next thing that's important is we want to check the network. And here, cool, we've got 10 connections. It means we're connected to 10 other peers. And this number, if you want to be an active participant, or I guess you could say an extension of the network, this needs to be greater than 8. Otherwise, all you're doing is you're just copying information to you. You're not actually allowing anybody else to use you as a peer. So you're only a one-way player, so to speak. So you're not actually helping the network proliferate at all. So anyway, just one thing to say, and you can set things up so that you just have 8 connections, and which means you'll only be receiving incoming data. And that's fine. That's actually, for some people, probably better from a security perspective. It just depends on what your goals are. But for me, I don't mind being a contributor to the network decentralization and security. So that's why for me I'm okay with leaving it open. Okay, this means that everything's running correctly, or running as it should. So at this point, what we can do is I'm going to go ahead and stop. Ooh. So one thing to note is always try to use the Bitcoin CLI. If you manually stop it with like Control C, sometimes it will be hard to start again. So we're going to go ahead and stop that. And then if you notice, it should interrupt this process here. And eventually it'll shut down gracefully. Give it just a minute. There we go. All right. So now what we're going to do is, now we've made sure everything's working and all the setup is correct. We'll go ahead and we'll start it back. But this time we're going to start it back as a daemon. And all that means is it's just going to run in the background, so we don't have to keep this terminal alive in order to keep the process running. So we'll go ahead and start that. And then basically the process is going to start, and it's just going to run in the background. So another thing we can always check again, we'll give it just a minute, but as soon as it starts running again, we should be able to run these commands. Boom. And boom. See, it only got 7 connections this time, because it's having to go back and remake those connections with peers that it broke when I killed the process. But anyway, you guys get the idea. So now everything's running. And you should be able to sit here and look and be able to basically refresh. Wow, it's down a lot already. But you should be able to sit here and hit the refresh button and notice that the numbers keep increasing. I forget what the last thing we had downloaded was. Let's check it out. All right, so block 00477. So let's see how quickly things are changing. 00477. Oh, well, I guess they're not changing that fast. But anyway, you guys get the idea. If you sit here and you do that long enough, eventually, they're pretty big files, 128 megabytes apiece. But eventually you'll see that change. So anyway, guys, hope that you found this helpful. I didn't find a lot of good stuff on this on YouTube, so I figured I would make a video myself. I hope you guys enjoyed it. If you have any questions, just leave in the comments, and I'll do my best to address them. And I'll see you guys in the next video. All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear or if there are anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.